So I don't even know if anybody thought about this yesterday, okay? But when we were doing our division rule and we were subtracting exponents, was anyone ever worried about the denominator having a larger degree to where when we subtracted, we'd get a negative number? Somebody did worry about that. Okay. Negative exponents are a thing, but a thing that we cannot leave in a simplified answer. So if we have a negative exponent, we have to readjust. And if we have x to the negative a, that just means we have to take our exponent across the division bar so that it can become positive, okay? So x to the negative a means 1 over x to the a. As soon as it travels underneath, as soon as it travels across that division bar, that fraction bar, it becomes positive. Okay, now, where this gets really exciting is when we have more than just one variable, okay? So like this right here, this is straightforward. X to the negative fifth just means 1 over x to the fifth, okay? However, if you look at number 2, does 3 have a negative exponent? It doesn't. That's just 3 to the first. 3 has a positive exponent, which means 3 doesn't move. It has a positive exponent, but m to the second power goes on the other side of the fraction bar. In number 3, who has a negative exponent? Only a has a negative exponent. Negative 7 is just negative 7. It has technically a positive exponent, right? We're not going to write it. B has a positive exponent. But since a has a negative exponent, we have to move it across the fraction bar to the other side where it becomes positive. Okay. Now, simple when it's by itself. A little bit more interesting when we throw some other rules in there. Okay. So, what I want you to do, I want you to look at number 4. Okay. I want you to look at number 4, and I want you to talk at your table about what you think should happen in order to get a simplified answer. I want to hear lots of talking. Go.
Look at this. W over 7 and W. Add them together. W over 7 and then W over 1
Okay, so what I would look at first is we're multiplying, right? Okay, so I like that. So now we need to simplify. Well, I think that 7 W's can cancel out to where we have 2 left over downstairs. Right?
Yeah, I got so many questions like this. I'm like, I don't even get it.
I actually managed to guess it.
I don't
Yes.
get that. What does that even mean?
What is it when there's like an exponent
And that would be like 1 over.
What?
What is it when there's like a number they bring in?
That's a
Would it
subscript.
just be 7/9?
Okay.
So it depends
Would it
on
just be
the
7/9 W to
context.
the 7
I had it
divided
in the
by
math test.
3 to the 9.
Okay,
Oh,
it
okay.
depends
Would it
on
be like
what it
this?
was talking about. It was probably talking about a sequence.
Would it technically be look like this?
The arithmetic sequence.
No. Hold on. Hey, we're going to talk about it. Okay, how many of you rewrote this as a fraction and then simplified? That's what you did. Okay, how many of you did the product rule and you added your exponents and then rewrote it? Okay, so you can take two different ways. Okay, you could say, hey, I can add my exponents together and then I can rewrite it to be a positive exponent. Okay, some of you saw this problem like this. Oh, this is w to the 7th over w to the 9th. I have no problem with that. Well, now what happens? We subtract our exponents. What's 7 minus 9? So we have w to the negative 2, which means 1 over w squared. Okay? Or you can think of it like this. You can think of, oh, hey, and maybe you don't need this step right here. Maybe you know that I'm subtracting 7 minus 9, but it's negative, so I know I have to write it like this, okay? Either way, it's the same amount of processing, okay? Our brains work in different ways. Either way you go about that is fine. There are some operations that we better do a certain way, but that would be completely fine, okay? How do you want to attack number 5? What is going to be the best way to attack number 5? Should we rewrite it first or should we multiply first? What would be best? You want to multiply first? Yeah. Let's try it. So 4 times 5 would give us 20. C to the 8th times c to the negative 5th. When we add those exponents, we would get 3. And then d to the negative 3rd and d to the negative 1st. When we add those exponents, we would get d to the negative 4th. So your answer that I would want to see is 20c cubed over d to the 4th, like that. Negative exponents cannot be left in our answer.
You get that, Derek?
All right. You do number 7.
Oh, yeah.
If you haven't done so already, check in with your neighbor to see if they're getting the same thing as you.
So neighbor, did you get the same thing as me? Thank you, Derek. Why are you bullying other cousins, Derek? Yeah, give me that. Get it, Derek?
All right. Is this what you have?
Oh, yeah. Yes.
Cool. Okay. So now let's talk about how number 8 looks different.
Oh, wait, how'd you get that wrong?
Joey, did you ask a question?
I put AB to the 7th.
Okay, well, I didn't hear you ask me a question, so you can't get upset. Okay. We can't combine the exponents of a and b because they're different variables. We have to leave the 2 with the a, and we have to leave the 5 with the b. Okay? Do you know why? Okay, look at number 8. I don't know what I'm supposed to do. I really do. But I want you to help me.
Why?
What do you think I'm supposed to do?
Yeah, Leah.
Did you have an idea?
He's calling me out, guys. Audition. Right?
Audition?
What do you... He's calling me out for no reason.
What do you think, Ella?
Yeah.
Would you do the
I still did. Guys, look, I still did. I still got the answer.
So are you saying that we can like take this through like that?
Oh, I'm talking about 5. My bad.
So like 8 to the negative 2.
I'm talking about this one.
Hold on. And p would be to what power? Negative 10. So Ella's suggestion was that we take the exponent and we put it through just like we would with our power rule. Okay? Now, here's where people get... yes. This is a negative exponent. What do we do with negative exponents? We don't panic. We put them on the other side of the fraction bar. So 8 squared has to move to the other side of the fraction bar. P to the 10th has to move to the other side of the fraction bar. So this is really 1 over 64 p to the 10th.
Could you do the 8 to the -2 power and then switch it? So it'd be like -64.
So it wouldn't be negative 64 though. It'd be 64 to the -1. Like the exponent is still negative. Does that make sense? Okay. Now, maybe your brain wanted to panic about the negative exponent first. You could have done this. All right, I'm moving the negative exponent down to the denominator and then done it. Okay? But I think that this way is how most of our brains are going to process it, and I think that that's a good way, especially if we have something like number 10. Okay? So I would suggest sticking with this way. Right? Okay, so how about you just try number 10, see what you and your people at your table can come up with. It's a little bit different, but a little bit similar. Okay. I don't hear a lot of talking, which makes me a little sad. I'm wanting you to like actually check in with the people at your table. Like this isn't a solo thing.
So wait, is the fraction bars with negatives on the bottom and positives on the top?
For exponents, yes.
Alright, yeah.
So like this guy would stay and this guy would have to go down. Now 3 to the -4 is not 12. I want you to rethink that one. Nope.
Oh, it's
Well, yeah, it's 81 in the denominator. You were right, Joey. No, it cannot. R needs a 4, and then that's all you have to do.
3 times 3 is 9. 3 times 3 times. What? 3 plus 3 is 9. Wait.
All right. What's up?
Would this be a negative one then? Since it'd be negative 11 to the second down here.
So 11 to the second power.
But would it be negative 11?
Okay, negative 11 to the second power is still going to be a positive. Okay, I talked about this the other day when you probably weren't listening to me because you're doing your homework instead of listening to my lecture. All right, here we go. Who feels like, yeah, my answer's pretty good?
Me.
Okay, Theo, what do you have?
I got RS to the power of 12 over 81. I don't know if I did the exponent correctly.
So I like s to the 12th, and I like over
I
81.
forgot to add the exponent to R, my bad.
You did. So what exponent should be on r? Where? Okay, negative 4, which means r to the 4th needs to be downstairs, okay? So I'm seeing a lot of this. 3 to the negative 4, r to the negative 4, s to the 12th. I'm seeing we did a pretty good job here, but an exponent is still an exponent. I saw a lot of 3 times 4, and I know that that's tempting because we multiply those exponents, but if we have 3 as a constant, it's our coefficient, we have to take 3 to that power and then adjust. Okay? All right, let's go to number 13. Okay, I'm not looking for the simplified version yet, but I'm looking for, when I perform the operation, what the power for C and the power for D would be. Thoughts? Camden. Negative 9 and 1. Okay. David, how did he get negative 9?
because the bottom one's already negative.
Okay, so what do we need to do with our numbers, our exponents, when we subtract, when we divide? I hate when I do that. Okay, we need to subtract. So we have to take negative 2 minus 7. What's negative 2 minus 7?
Negative 9.
Negative 9. That's how Camden got negative 9. Okay. Willa, how did he get 1? Negative 1 minus negative 2 is going to get us a positive 1. We are subtracting our exponents here. So, D to the 1 can stay, but C to the 9th gets kicked downstairs. And by downstairs, I mean the denominator. Just so we're clear. Okay. Sorry, I'm trying to decide which. Is there any of those between like 14 to 19 that would cause you to, maybe I want to go over this before I do my homework?
No, we should do 18.
Bro.
Yo.
We all want to go to our homework and you're like almost the first.
We know how to do all this,
Okay, this is what we're going to do. We're going to do number 23, and then we'll do our homework, okay? Okay. What is the first thing we need to do in 23? We need to do the exponent. So let us please do this first. We're going to have 9x squared y squared if we do the exponent first. All right, now what do we do? We've already done the exponents. P-E, multiply. Let's multiply in our numerator. So now our numerator becomes 9 times 2 is 18. X squared times x to the 4th is x to the 6th. And y squared times y cubed is y to the 5th. Okay, now we can finally do the division. What's 18 divided by 6? 3. If we subtract our exponents, 6 minus 8 is -2. Do you agree? Which means we are going to have x to the -2. So I'm just going to bring that downstairs right away. Okay. And then y to the 4th. And where does that go? They're playing a game over there. I almost had to go check on them 5th hour because they were really making me nervous. Okay, so here's what I'll say. Right now, I want you to focus on page 13. But when you are done with page 13, if you go back to page 12 and you do the challenge problem with work and a correct answer, you can earn a piece of candy. You have to do page 13 first.
Oh, did we just show it to you tomorrow?